to motivate the concepts that are part of statistical inference, we're going to briefly look at the results presented in a paper in this journal here, Diabetes. And we can see that this paper is reporting on an experiment that involved mice and feeding them different diets. And one of the conclusions we see in the abstract right away is that body weight was higher in mice that were fed the high-fat diet already after the first week. So that is a scientific conclusion. So how did they come to this conclusion? And that's one of the things we're going to explain here, and also to explain how statistical inference is involved in this conclusion. So if you go down further to the results section, where they convince us that that's the case, you see things like body weight was 16.3 plus or minus 0.1. So what is that plus or minus there? And then we also see that we found differences of 2 plus or minus 1, and then there's this p there, p less than 0.001. So that is a p-value. It's in one of the concepts that we're going to describe in this course. Okay, so how do they come to these conclusions? So to do that, we're going to perform an analysis similar to what was done in that paper. So we have data from mice that were fed 2 diets, and what we want to know is if the high-fat diet in fact makes mice heavier. Right, so what we do is we collect data, we sample, for example, in this case, for example, we sample 12 mice. We get 12 mice from Jackson Laboratories. We get another 12, and these were randomly selected. We feed 12 of them the high-fat diet and the other 12 the control diet, and then we compare them. So the data set that we've been looking at is, in fact, a data set from such an experiment. So we can load it. We've done this before. We can load it with the function read CSV, and then using dplyr commands, which we have seen, we can separate the control measurements from the treatment or the high-fat diet measurements. Right? So there we have it. So we ran these dplyr commands that take the chow and compare it to the high-fat diet, and now we have 2 lists of numbers. So we have the controls and we have the treatment. There they are. Okay, so now if we compare these 2 mice, we can see just by looking through the 2, we see that it's not always the case that the high-fat diet mice are heavier than the controls. For example, we compare this mouse that received the high-fat diet. It's lighter than this mouse that received the control diet, and there's many examples like that. So when we say in many scientific statements like high-fat diet makes mice heavier, we are talking about a comparison of the averages. So we're saying on average, the high-fat diet results in heavier mice. So we can do that here. We can compare the mean of the treatment group to the mean of the control group, and we can see that in fact the treatment group is about 3 grams heavier than the control group on average. Now, in the paper we saw these plus or minuses, we saw this p. What are those concepts, and how do they relate to the conclusion that we reached? So the reason those numbers are shown is because we could have obtained different values than 26 and 23. For example, by getting a different group of 12 mice and getting a group of mice who just happened to be heavier or happened to be lighter, then these numbers will change. So these averages that I'm looking at here are what in statistics we call random variables. So in the next video we're going to show you what that means using computer code.